Electric charge. The trick that we used to do with the balloon to make our hair stick up, or of course, a lightning strike. They are all governed by the same principle, static electricity. Static electricity occurs when an object obtains a net amount of positive or negative electric charge, creating an imbalance that wants to be returned to equilibrium. Its effects aren't always as intense as the lightning though. For our experiment, take two pieces of tape that are both stuck to a table. If we rip them both off the table and try to stick them together, that should be easy enough, right? But it turns out that they repel one another. But try this. Stick one on top of the other, rip the pair off the table, and then separate the pieces. They're no longer repelled. Now, they're attracted to one another. In the first scenario, both pieces of tape stole negative charges from the table. And since like charges repel, the pieces move away from one another. In the second scenario, one piece of tape stole negative charges from the other, leaving the pieces with opposite overall charges, making them attractive.
To fully understand this lesson, atoms contain charged particles, positive proton, and negative electrons. And generally, there's an equal number of each, meaning the net electric charge of the atom is zero, meaning to say it is electrically neutral.
In solid materials, protons stay fixed but some electrons are free to move around. These moving electrons are called free electrons. Free electrons reside in an atom's outer shell as valence electrons and are easily plucked off and carried around when acted upon by an outside force.
How easy it is for electrons to move around depends on the material, and we describe the material in the same manner we do for heat transfer with conductors and insulators.
Materials that are conductors, like copper, let free electrons move freely throughout the solid. Insulators, like wood, hold on to them tightly, limiting their flow. So we've got insulators and conductors with free electrons moving around in them. But what causes these charged particles to move in the first place? The answer is an imbalance of electric charge when some part of an object has a different number of free electrons than another part. When we talk about an object having an overall negative charge, we mean that it has too many electrons. And when we talk about an object having an overall positive charge, we mean it's missing free electrons. This imbalance can be created and resolved in lots of different ways.